Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, today in this tutorial we will discuss how to generate a 3D model for that configuration by using SEG software, and how to make this ellipsoidal head with the defined crown and knuckle radius, how to create this attachment as a nozzle, and how to attach those two nozzles, one of them with internal projection and external projection, and the second one was only external projection. And here we have an convex head and how to add a nozzle to this convex head. Now let's generate a new project. Select the location for this project and click finish to start creating the project files and folders. Okay, now let's add an ellipsoidal. Select the project, the vessel node from the tree, and from here select the equipment setting and define the position of the vessel as a vertical, and make the arrangement of this vessel from bottom to top, and select the units of this project as inches, not millimeter. Now let's save that, and from here select the vessel, and from element let's add a head as a bottom head, and from here let's select the user-defined crown and knuckle radius. Okay, so from here let's define the inside diameter. It's 164, and for the thickness it's ½ inch, and for the straight flange it's 3 inches. Minimum thickness after forming, let's make it 5, and here for the crown radius it's 164, and for the knuckle radius it's 8 inches. So it's 8 inches, and create it as a flipped head. Now let's generate the 3D model for this head. Now we have this ellipsoidal head with crown and knuckle radius. Now let's add a boot nozzle, which is that part. Okay, so from here let's select this nozzle and name it as boot. From here, let's define the outside diameter of this one. As mentioned here, the inside diameter is 41 inches with thickness ½ inch. So the outside diameter will be, so from here, let's select it nozzle from plate and define the outside diameter to be 41, and the thickness is ½ inch. And the longitudinal building line, let's make it 0. Okay, from here, let's define the welding line gap, keep it as it is, and the offset from vessel center line, let's make it 0. And the projection of this nozzle, it's not mentioned here, but we could make it as a 50, so let's make it 50 millimeters and click save. Now let's generate this nozzle. So it will be a nozzle from plate with 21 inches as inside diameter, with ½ inch as thickness. Okay, here we define the projection as a complete 50 millimeters. Actually, we define that length is 50, but we need it from the seam line as a 50. So we need to come back here for the calculator and define the offset, the projection from vessel seam line to be 50 millimeters. And click on save. Now here's the calculated projection. It's 20 inches, around 20 inches, and now click save. Now we could make a quick drawing to measure the values from it. So from here, let's select metric and select an English drawing with English units, and from here let's add a base view from the back view and make the scale 1 to 10. And now let's check the dimensions. So from here, that's the inside diameter, it's 160, and here's the straight flange, the knuckle radius, and here's the crown radius value, and the inside diameter of this nozzle, and here we have the thickness, and the projection from here to there is 50 millimeters. Now let's add the nozzles. So from here, let's select this external point, and now let's add a connection point. As we know, in SEG software, we cannot add an attachment to another attachment. We need to make a connection point before creating that. We can add attachments to main elements only, not to another attachment. So from here, let's select the external point, and from here, let's add a boot connection point. Okay, and from here we will select an element so cover what we need. So from here, let's go back here, and at the end of this list, we will find a connection point for nozzle as a shell. Because this boot defined it as a shell, we have inside diameter, we have a thickness. It's not a standard pipe, so we can select connected point or connection point for a nozzle as a shell, and from here define the inside diameter as 41 and the thickness as a ½ inch. Now we have an unreal element located here at the end of this nozzle as a shell with the same configuration of this nozzle, and we can use it as a parent element to add attachments to this imagine part. Now, so from here, after clicking on save, we can use this one to add the first nozzle, which N1 with a external connection only, or external projection only, and from here let's select a nozzle from pipe, define the size and the scalable as 40. From here we have this nozzle as 10 inches with scalable 40. Okay, and from here make the location with a negative value, because here we create a parent element at the end of this nozzle. So if you add the projection with a positive value, you will move in that direction. So we need to move on the negative direction to come back to this point. So let's make the location with, let's say, 10 inches right now, and after that we will calculate from the drawing the actual value that we need. And let's add a nozzle flange here, nozzle flange, so N1 flange. And from N1, let's select slip-on flange, keep the rating as it is, define the size, and here's the offset of the nozzle from the facing. Let's make it 10 inches, and let's come back to the nozzle and define the projection from the vessel center line. Here we have the vessel, and here we have that projection as 10. So from here to there, from here to the outside, it's 41 divided by 2 plus half. So it's 42 divided by 2. So it's 42 divided by 2, which is 21, or 24 divided by 2 plus ½ inch, which is the thickness. So it will give us 21. So we will add 10 inches, which is that value. So the projection from the vessel center line to the facing of the flange is 31. So from here, let's add the projection as 31 inches and click on calculate. And here it's 9.5, and let's click on save. Now let's create, here's the orientation. Let's make it like that and click on save. Now let's start the assembly. Okay, here we have this nozzle like that, and the attached flange to this nozzle. Now if we come back to the drawing again and measure the location of this nozzle to adjust the location, as mentioned, we add a roughly location. We need to make the location of this nozzle equals 42 from the seam line. So let's come back to the drawing and measure the current value. It's 40. So we need to increase this value by 2 inches. So this distance from here to there, we need to decrease it with 2 inches. Okay, so let's come back here, and from that one, let's decrease that value to 8 inches. And let's add another nozzle with internal and external projection. So let's select this one and make it as N2. And from N2, let's define this nozzle as 10 inches with a scalable 40. And from here, the location minus or negative 8 inches. And the orientation is 80 degrees. And click on Save. Now let's add an external flange, which is N2 flange. Okay, and for N2, let's make it looks like N1 flange. They have the same definition. And for the internal connection point, let's add an elbow. So it's N2 elbow. Okay, and from here, let's select elbow 90-degree long radius, define the size, the same pipe size, the same scalable, and click on Save. Okay, now let's come back to the projection of this nozzle. And from here, from the calculator, let's define the projection of this one at 31 from the vessel center line, and click on Start Assembly to start creating this nozzle, which is nozzle N2 with internal projection. As you can see, the location of the first nozzle updated, and now the second nozzle, which is N2, will be generated with internal projection. Okay, as you can see, the orientation of the elbow goes to the below direction. We need to change it. So let's come back to the elbow and update the orientation to 180 degrees and click on Save. Now update the orientation of this elbow to make the direction of this elbow goes to the up direction like that. And now let's come back to the drawing to check the values. Here, as you can see, the projection updated like that. If we measure it from the vessel center line to there, it's 24, and the projection of the nozzle from the facing of the flange, it's sorry, we need to make it to that datum. So we need to measure it from the facing from here to there. Now it's okay. Now, as you can see, the elbow, we need to make it with the same center line of the vessel. If we take a look to this sketch, this pipe have the same center line of the vessel. So we need to decrease the internal projection of this nozzle. So let's measure the required value. So from here, let's measure the distance from the elbow center line to here. So we need to decrease that value from the internal projection of this pipe. We have this internal projection, so we need to decrease that value a little bit. So let's come back to the nozzle. And from here, let's take this value, which is the internal projection, which is 7.874. And let's decrease 3.09. Let's check that value. Yes, it's like that. And click enter. Now we have that's the value of the internal projection, which makes the center line of both are equal. Now, one more thing, let's check it, which is the required length of the pipe. We need to add a pipe here with 27 inches length. So from here, let's select the internal projection, and from here, let's add into pipe. And this pipe, let's make it 10 inches with scalable 40 and with 27 inches length. And from here, click on Assembly to start creating this internal pipe. Okay, let's open the drawing again and check the value. So the offset become now 0 equals 0. So let's remove that. And here we have the projection of the nozzle equals, give us the same value for the seam line. Now let's add a convex head here to the end of this pipe or of this nozzle. So from here, let's select the external connection point of this boot. And from elements, let's add convex head. And let's select this convex head, and from the types available here, let's select convex head and define the inside diameter as 41, and the thickness, let's make it 0.5, and the height, let's make it 3 inches, and the minimum thickness after forming, let's make it half and make it flip. And now click on save. Now let's run this convex head. Like that, we have this convex head here. Okay, now if we take a look to this convex head and the elements available on this one, now we don't have nozzles to attach it for this convex head, but by another way we can add nozzles or other attachments to this convex head. This convex head is a part of a sphere head. Okay, so if we add a center line of this one, if you can imagine, let's imagine that we have an ellipsoidal head. Okay, here. Let's imagine that we have a head start from this point. So let's add this center line. That we have a head like that here. Okay, so by using this unreal head, we can add nozzles to or other attachments to this convex head. So how to do that? In SEG, we have an option, some options to do that. So from here, let's come back to the external, to the main element, which is that head, and let's add an offset with that value. Let's add an offset with that value, add a gap, and from here we will add a hemispherical head as a real element. Okay, from that center. So we need to move to the center of this head first. So from here, let's select the boot head, and from here let's from the bezel, let's add a gap. So from here let's add a gap and select this gap, and this gap value will be 18.54. So from here 18.54 and click on save. Okay, now if we create if we create the assembly, we will get an element here, an imagination element called gap, and as you can see, we have here the UCS or the connection point of this element. Okay, located at here. Okay, at that point. So from here we will use this point to create an unreal element, looks like the hemispherical head. So from here let's select the bezel again, and from elements let's add a head as a convex head connection point, and click create. And from here, if we come back down here, we will find a connection point as a hemispherical head. As you can see on the image on the right hand side, this item is not a real item. You can use it to add attachments to an element as a hemispherical head. So let's define the inside diameter of this head. So let's come back to the drawing and measure the value, the inside radius of this cap. So that's the inside radius. If you would like to calculate the diameter, so from here let's get the diameter. So the diameter is 143.08, 143.08. Okay, so that's the inside diameter, and the thickness is ½ inch, and it's flipped. Okay, so let's click on save. Now we will generate an unreal element, and if you select it, you can see that you have all the attachments that you can add it on the hemispherical head. Now let's add the nozzle as N3, and from here, if we come back here, this nozzle is 8 inches with 40 as a scalable. So from here, let's select 8 inches with a 40 as a scalable, and the offset is 0 from the bezel center line, and let's click on save. And now let's add a flange, so N3 flange. From here let's select this one, select slip on, and the size is 8 inches, and make the offset is as a ½ inch, and click on save. Now to define the correct projection of this nozzle, as you can see here, we have that projection which is 61.5 from that seam line. Okay, but as you know, we will add this nozzle from on a hemispherical head from that center line. So we need to measure the value from here. Okay, so the value, which is 61.5, we will add that value to it, which is 18.54. Again, let's add this value, 61.5 plus 18.54. So that's the projection from the seam line of the hemispherical head, which is unreal element, not the actual one. So let's add this value here and click on calculate. Now SEG will create a sketch here to calculate the required value, and here we have that projection. So let's click on save, and now let's click on start assembly to start creating those items. Okay, now we have this nozzle, and if we try to measure the values, as mentioned, we will measure the value from the facing, from that face to the seam line. It will equal 1 point, because we measure the value from here to there. When we calculate the projection, we calculate it from that element. Okay, so now if you try to add a shell, actually you will start creating the shell from this point, not from that point. Let's try that and check how we can resolve that. If we have a shell after this can, let's add can 1 like that, and define the inside diameter as shell, and here we have the inside diameter 164, so it's 164 inches. The thickness is half millimeter, and the orientation, keep it as it is, and the length we could make it 100, and click on save. Okay, now if you click on create the assembly, you will get the shell with a gap. Okay, because we add a gap to create the unreal element, which is the ellipsoidal head. To solve this issue, we need to add an offset with another value here. So from elements, let's select a gap, okay, and add gap 2. And from here, let's select overlap, okay, and reduce the same value here. Okay, and from here we need to add this gap before the can. So from here, let's move before can 1. Okay, so we have this gap before the shell. If we click on start assembly, as you can see, we moved back to the end of this point. So now you can start creating your elements from the end of the shell. Okay, I hope in this tutorial video we learn how to make some unreal elements, like adding a connection point to the end of the nozzle, to add a nozzle to another nozzle, okay, and how we can use the unreal elements to generate or to use it to create nozzles to a convex head or something else, like a conical head with closed end or something like that. So we learned how to make something like that. Thank you for your time, and hope this tutorial can help you. Thank you so much. Assalamu alaikum.